So going on to the next bit, which is backtracking. So the definition for backtracking, looking at exam definitions and exam past papers, I have not found much on backtracking except for different examples. So OCR have currently not asked anyone or through any papers what backtracking really is. So if they do ask you, if it's a 1 mark definition, then 1 mark sort of question, then what is appropriate is pretty much saying backtracking is the process of incrementally building towards a solution. That should be suffice in getting you the mark. However, if they then do again ask you to extend, then just remember that it abandons partial success when the solution can't be completed, and going back to a previously successful match. Now you might be wondering what does this mean? So going back to what backtracking is that logic problems, especially the ones which, for example, involve you finding a path or finding an appropriate route, like in depth first traversals or other sort of traversals, or um, different areas in a game where you're going in a map and traveling. So in those sort of situations, it is pretty useful to use backtracking. Now, I can give you an example. For example, you're in a maze and you're going forward, and you're trying to figure out the most sort of appropriate route to take for this maze and complete it. Now, what backtracking would do is it would proceed forward, and when it reaches perhaps a junction where different paths diverge, it would pick a random route and go towards it and see where it does end up. Perhaps let's just say it ends up in a dead end. Then it will retrace its steps, go back to that junction, and pick another random route from there and go forward from there. And if it does not hit a dead end, then it'll continue with that route and keep repeating the process until it finds the exit. So that's how backtracking would work in terms of as an example. But there's also an example from OCR, which I have seen come up, is the depth first traversal. So what OCR has asked you for backtracking in. So if they do ask you again, perhaps this was, I think, asked in the 2019 paper, but I need to obviously double check. However, what they did ask you from the Mars game, it is exactly word for word, is that it is used by starting at the root node. So we start at the root and we go all the way down one branch until we reach the bottom. Now, from a visual aspect, this is just nothing clear to you guys, so I can get a quick picture to help you. So now, having a visual aspect, I have got a graph here. So we would start at the root, which is 1, and we would go all the way down one branch until we reach the bottom. So let's just say we reach 4 in this sort of example. So when reaching 4, we would store all the nodes from 1 till 4 on a stack. So let me go to get that down. And all the nodes which have been visited are stored / pushed onto a stack. Again, definition term from the Mars key. Now, when we cannot go down any further from here, right? We go down to 4. We can't go any further any more down. Then it will backtrack up, i.e. go to 3, and it will, in doing so, it returns to the previous node, and it will go down all the way down that node. And through this way, we can sort of, go through and have a storage of all the nodes. So pretty much we're just continuing backtracking until a node with unvisited children is reached. So here we've reached 3, then we would go down this branch, get down to 5. Now we would backtrack up. Since we visited 3 and 4 and 5, we can go back up to 2 and go down that branch. And we can repeat this process until we have pretty much done a depth first traversal, which, as the core definition is, being an algorithm which goes as far down as possible. So here we have the first 2 points. This would typically easily be like a 4 to 6 mark question. So starting at the root node, we go all the way down one branch until we reach a bottom, and all the nodes which have been visited are stored pushed onto a stack. Now, when we cannot go any further down a branch, we would backtrack and return to the previous node. So we've gone down to 4, now we return to 3. And we'll go back. We'll go down that node. So after we have backtracked, we would continue until a node with unvisited children is reached. Now, once that has happened, we would then go down that branch, or go down / check that branch. So that would get you all those full marks in that question if it has came up, which is pretty much the backbone of what backtracking really is. I have seen questions where they might ask you, like from different examples, they might ask you about like a Sudoku puzzle or something else to do with a graph. So just make sure that if you know this, you can pretty much apply it towards any example OCR might throw at you during the exam. Now, the next bit in this OCR specification is data mining. Now, again, I have done my research on the definitions which OCR want you to know from the mark schemes, and gathered from assessing different mark schemes. I've gathered a overall definition for data mining. So if you do write this in the exam, you're pretty much guaranteed all those marks. So, as an overview, data mining is a sort of concept where you have a vast amount of data, which is perhaps gathered via like questionnaires, primary surveys, or other forms, for example, for collecting data. Once we have done that, data mining would analyze all of those vast amounts of data and discover from them, we can discover new information and different sort of trends. This is typically used in like AI. You feed in your data into the AI model. It can then make trends and sort of machine learn from that data and develop itself. Now, the OCR sort of definition for this is that you pretty much turn large quantities of data into useful information. So, turning large quantities of data into useful information. And through this, you can discover, and actually let's reword this, and this can then be used to discover new trends. So in the mark scheme, pretty much this new trends word is really crucial in getting you a mark, and turning large quantities of data to useful information. This sort of wording is pretty much the highlights of data mining. And you would, just actually extend this. You can discover new trends, and you can find new patterns. That's another word in the mark scheme which it is looking for. Now, this is pretty much done. Like, for example, I give the example before, you could take questionnaires, primary surveys, secondary surveys, all these sort of surveys where you can collect data, or you can maybe take people's opinion online through Google Forms, database inputs, all these inputs where you can gather data. Now, in the OCR mark scheme, it says that data is extracted through databases. So that's what they would want you to know. Data is extracted from databases, and we are looking for specific patterns or new trends from that. So data collection. And from this, the mark scheme also says that gathering this data, we can analyze it and not only find specific patterns and new trends, but we can also add in another slash here. Make sure just to add this in because mark schemes differ a lot. So we can find specific patterns, new trends, and can analyze, if I can spell that properly, analyze the data to make informed decisions. This is an absolutely crucial word in the mark schemes. Informed decisions. So I'm going to be highlighting that yellow because it's pretty crucial to know that. Now, going back to the next area. Now, if this perhaps is, let's just say, a 9-mark question, because 9-mark questions have came up before and they are literally on backtracking. They would have this being the AO1, and now you would pretty much have like the AO2 area, and this would compose pretty much of your answer. But then again, if it's not a 9-mark question, if it's perhaps a 4-mark question, they still would want these points and a sort of example or a backing up point. So what I have seen is that pretty much data mining might come up, like there might be a question on perhaps social media. And if it is for social media, then, well, you can put, I'm going to write down an example and just make sure you apply this in the exam. You can just take this points and all you got to do is take a few words, tailor it for the question, and that would get you all the marks. So